Hello guys, I hope everyone is fine. We are going to talk about runtime polymorphism in this series of video lectures. In this specific video lecture, we are going to discuss about runtime polymorphism, also known as late binding. So this is part 1 in this video series. Just a little bit of refresher. Polymorphism is made up of a Greek word. It is comprised of two words actually, poly and morphism. Poly means many, morphism means forms, so it indicates or it denotes the presence of one thing in many forms. Taking an example, all of us are students and all of us are sons or daughters of our parents. So we are talking about the same person, but the roles are different. And this is what polymorphism essentially means. There are two types of polymorphisms. If you look at the figure on the screen, it's compile time polymorphism and runtime polymorphism. Now we can achieve compile time polymorphism with the help of function overloading and operator overloading. Runtime polymorphism, on the other hand, can be achieved with the help of virtual functions. In fact, I would like to add here, runtime polymorphism can be achieved with the help of a combination of virtual function as well as the base class pointer. As is the case in our video lectures, we are going to look at a very simple programmatic example of polymorphism here, runtime polymorphism. I'm going to technically define it. Now we have a function call and we have some code which needs to be executed in response to the function call. When the code which needs to be executed in response to a function call is known at compile time, or this decision is taken at compilation, it is called as compile time polymorphism. And when the code which needs to be executed in response to a function call is known at runtime, then it is called as runtime polymorphism. Since this process is delayed, it is called as late binding. Binding refers to associating the code which needs to be executed in response to a function call, right? So that's binding. Since this decision is done later, it's also referred to as late binding. And in case of compile time polymorphism, this decision is early, so it is called as early binding. Let's get back to our example. So we will have single inheritance, which means I will have one base class which will have no data members. It will have a function called fun1 which will just print out one statement, base class. Then we would have a derived class which will contain no data members. It will have a function called fun2 which will again have one simple statement called derived class, or print out a statement called derived class. The main function will have a pointer, base class, so I will simply write, if my base class is called base, I will write down base asterisk ptr and I will call the function fun1. Let's get to the coding portion. My file is called poly1.cpp. I begin by writing or including the iostream file. I will use the standard namespace. I will go ahead and write down the base class, keeping up with our initial assumption. I'm not going to put any data members here. I will just have a function which does not return anything, does not take any parameters, simply prints out base class. The next thing that we will do is we will make a derived class which will publicly inherit from the base class. Now remember, this here indicates single inheritance, no data members, a function called fun2, and it prints out derived class. What we are going to do next is code out the main function, int main, and I will make an object of base class. My object is called obj. A pointer to base class is called ptr. Since pointer is supposed to hold an address, I'm going to give it the address of obj. Since I'm using a pointer, I will use the arrow operator, ptr arrow operator, fun1, and I'm going to compile and run it. So g++ poly1.cpp, got lucky, no errors there, and I'm going to execute it. It gives out base class. Now base class pointer has a special property. It can point not only to an object of the base class but also to an object of the derived class. This is something that we will explore in our next video. Take care, be safe.